Hello all, welcome to this course on Elements of Mechanical Engineering. My name is Atchuta Ramacharyulu and I am working as an assistant professor in the Department of Mechanical Engineering. In this lecture, we are going to see what are the different ferrous materials and their alloys. In the previous lecture, we have seen what are the different types of iron that are available in the nature and how they can be converted into different forms of steels and other forms of iron. Now in this lecture, we are going to see what are the different types of cast iron, what are the properties of them and applications where these different types of cast irons can be used efficiently to prepare different types of objects in the engineering application. Now the next type of cast iron is white cast iron. So white cast iron contains about 94% of iron and the carbon percentage is of about 0.5%. So it contains 0.5% of carbon. Previously, in the previous lecture, we have seen grey cast iron which contains about 2 to 3% of carbon. So depending on the percentage of carbon, the property of a particular cast iron will changes. Okay, so the total combined percentages are about 3.5% and remaining are all other impurities like silica, etc. Because this is digged out of earth, it will definitely contain silica. Now there are some properties which makes this white cast iron very special. So this is hard, brittle and cannot be machined at all. So this white cast iron is the one which cannot be machined. It is so hard that it is very brittle and it cannot be machined on a machining device. So it cannot be cut. Okay, it cannot be made into two pieces or it cannot be turned out into a new shape. Okay. Now, and the second property is highly resistant to wear. So whenever a object is made up of white cast iron, it does not wear easily. So this property makes this white cast iron very important. Why? Because it is used where we have to use the tool for machining other metals. So along with that, some other applications are there where these white cast irons are used. Okay, we are going to see those uses in later in this slide. Now the next property is tensile strength is very good for this cast iron. So generally cast iron has brittleness. Due to brittleness, it cannot hold tensile loads. But this white cast iron is different. It can carry tensile loads also. Not up to the mark where it can exceed the tensile loading capacity of a ductile metal, but it can take higher amount of tensile loading than the cast iron, which is grey cast iron. Okay. So the tensile strength is more than the grey cast iron, but it is not more than the mild steel. So it is obtained by rapid cooling of metal. We know this technique when iron is heated to its recrystallization temperature and it is cooled rapidly. Then we will get this form of cast iron where it shows very brittleness. So this is very brittle material where it can be used for the production of freight car wheel, okay, railway brake blocks, etc. So this, whenever we want to use this white cast iron in any engineering application, because of its brittleness, it has to be made in such a shape where it has to be very bulky or it can be very large in shape and diameter. Okay, that is why it can be used for subjected to excessive wear when the surrounding area or environment around the metal object is prone to wear. So that is when we will go for white cast iron. So some examples of the applications of white cast iron are rim of the freight car. Okay, whenever there are cars in olden times. So now freight car is nothing but it is the car wheel which is made up of white cast iron. Okay, and wheels of railway brake blocks. Whenever we take the example of railway wheels, that means locomotive engines and their wheels, they're all made up of this white cast iron because they are very wear resistance. Sometimes the brake shoe of railway engines are also made up of this grey cast iron because this grey cast iron does not wear easily, so it cannot be worn out. It will take more time. Okay, now the second application is used for inferior castings and does not rust so much as grey variety. So another good important property of this white cast iron is it does not rust easily because it does not combine with the oxygen that is present in the atmosphere. So it will resist for corrosion up to some extent. So that is why they can be used for inferior castings, so that they can be converted into metal objects which can be used in the open atmosphere. And then third application is used for making malleable castings also. Whenever there are malleable castings are there, for preparing the malleable castings, we have to use some kind of die. Those dies are made up of this white cast iron. Now we are going to see another type of cast iron, that is mottled cast iron. Here the graphite percentage is 1.75 and carbon percentage is about 1.75. Totally, the total carbon percentage is of 3.5%. Here the iron percentage is different. Iron is about 93.5%, and some of the good properties of this mottled cast iron is it is a mixture of two states, grey cast iron and white cast iron. So it is a combination of these two. So when the iron is being processed in the furnace, when it is being converted from cast iron into, that means grey cast iron into white cast iron, we will get a separate form, that is a mixture of these two. So it will have the properties of both grey cast iron and white cast iron. So that is why this is called mottled cast iron, which means it is a combination of two or mixture of two cast iron forms, where it has particular property, that is strength and hardness. So both of the properties will be seen in this type of cast iron. So strength and hardness varies according to the ratio of free carbon to combined carbon. So here we have two forms of carbon that is present in this mottled cast iron. So that is, one form is in the graphite form and the second one is combined carbon form. So depending on this combined carbon form percentage, the properties will vary. Okay, and the third important property is less tendency to rust than grey cast iron. So this cast iron has the properties of both grey cast iron as well as the white cast iron. So generally white cast iron does not rust easily. So that property will be seen in this mottled cast iron also. And one important property of grey cast iron is that it is very brittle. So that property is also seen in this metal. Okay. So both the good properties of grey cast iron and white cast iron are seen in this mottled cast iron. And this is very hard and brittle at the same time. So let us see some of the uses of mottled cast iron. So it is used for manhole covers and pipes. Manhole covers are still made up of steel, that is cast iron, and pipes are no longer in use because plastic PVC pipes has come into picture after the invention of plastic. So the iron pipes are no longer in use. And the second application is they are employed for making fire plugs and lamp posts. So whenever we have a fire accident, so the fire engine people will come and they will connect their fire engine to a hole. That means a fire truck will be connected to a fire hydrant pipe. So these pipes are made up of the fire plugs. That means they are made up of mottled cast iron. So they have very high strength capacity and also they have very rust proof. They do not rust easily. So that is why the lamp post, the pillars which are used for lamps, that means for street lighting, These lamp posts as well as fire plugs are made up of this mottled cast iron. Okay, so let us see another type of cast iron, that is nodular cast iron. So nodular or ductile cast iron is a very special type of cast iron where it is showing a special property, that is ductility, which is not seen in any kind of cast iron. So this cast iron has the ductile property which makes it special out of those all different cast iron types, where the carbon percentage is of about 3.2 to 4.2% and silicon is 1.2 to 3.5 and etc. Other impurities are there. Here the carbon ranges from 3.2 to 4.2%. Very large amount of carbon is present. So what can we observe? When the carbon percentage is increasing in the metal, we can see it is showing some very good features, very good properties, which is making the particular iron special. So with increase in the carbon property, the ductility will also slightly increases. So it is produced by ladle addition of nickel magnesium alloy, and it is cheaper to make and behaves like steel. So this nodular cast iron is very easy to prepare, yet it is very cheap when compared to other forms of steels, because those steels will take more refining process than this nodular cast iron, where this nodular cast iron shows ductility property very similar to that of steels. So some important properties are, it has very good machinability. So this can be converted into required shape very easily by machining on any kind of lathe machine or drilling machines, etc. So it possesses damping capacity intermediate between cast iron and steel. So the damping proof capacity of this nodular cast iron, this value will stay between the cast irons and steel value. Okay. So when we compare the vibration controlling capacity or the damping capacity of steel and cast iron, so steel will have more damping capacity when compared to cast iron. So this nodular cast iron will stay between these two, cast iron and steel. So another important property is it possesses excellent castability and wear resistance. So castability itself indicates that this metal, this cast iron, can be easily melted and it can be poured into required form of mold. Now, if we see the uses, so it has many uses like valves and fittings are made up of this nodular cast iron, and then internal combustion engines parts are made up of this cast iron. Pumps and compressors are also made up of this cast iron. Paper industry, machinery and construction machinery. See, there are multiple applications of this nodular cast iron. Because of the extra percentage of percentage of carbon that is present in this iron, its properties has developed much and it has wide applications than the previous one. Previously, we have seen some cast irons where they have to be bulky in shape and size so that they can be used in a particular application. But this cast iron has the ductile property which makes it more machinable and it can be converted or shaped into smaller size objects where it can be used for different applications. And then we have malleable cast iron. So malleable cast iron is another form of cast iron where it contains 2 to 3% of carbon and silicon, magnesium, etc. are there. So these are all very small percentage where they can be called as impurities because they does not affect the properties of iron anyway. So the important properties are, it possesses very good resistance and vibration damping capacity. So when we call about wear resistance and vibration damping, so this malleable cast iron has high damping capacity and it does not wear easily. And when we see the uses, so differential and steering gear housing, so these are all made up of this malleable cast iron. Now differential is a device which is attached to all the automobiles which are four-wheelers, where using this differential the speed or the rotations of the rear wheels are controlled. And steering gear houses are also made up of this malleable cast iron. Brake pedals, tractor springs, hangers, washing machine parts, agriculture implements, universal joint yokes, automotive crankshafts, railroads, etc. All these different types of devices are made up of this malleable cast iron. That is why the malleable cast iron is almost similar to mild cast, that is mild steel casting, but it has some form of ductile, brittle nature, ductile and both brittle natures. So, because of this carbon percentage, we have got these properties. And then we have another type of cast iron, that is alloy cast iron, where the cast iron is supposed to be very hard, brittle, lacking in tensile and transverse strength, and weak to withstand shocks. It is alloyed with other metals to improve its properties. Generally, what happens? Any cast iron will be brittle, because most of the forms of cast iron is very brittle in nature, and it has to be used in a particular manner or way where they can not produce a crack or break. That is why we have to do some kind of technique, or we have to apply some kind of process on this cast iron in order to make it good in tensile loading as well as other types of loading while absorbing shocks. So that is why the alloy cast iron is prepared. There are two types of alloy cast iron, where the first one is acular cast iron and spheroidal cast iron. So whereas this acular cast iron, when nickel and molybdenum are the leading constituents of the process which is employed to alloy cast iron. So the cast iron is treated with nickel and molybdenum. So then we will get acular cast iron. And then when the graphite content in spheroidal form, which increases the tensile strength and produces tough metal which can undergo bending and twisting also. So when we increase the graphite percentage in cast irons, we can increase the properties like they can be bended. The cast iron can be bent. So generally in cast iron, bending cannot be seen. When we apply some load, it will simply break and fails. So if you want to induce the property of bending and it can undergo high tensile loadings, then we have to increase the percentage of graphite present in them. Next, so far we have seen different types of ferrous metals. Now we are going to see non-ferrous metals. So this is one kind of non-ferrous metal where it does not contain any kind of iron. It is completely different branch of engineering where we are going to study non-ferrous metals. So these metals does not contain any iron, but they have their own properties and applications. So in that, the first one is aluminum. It is very abundant in Earth's crust. It is never found free, or nor it can be present methods can be obtained from clay, which is exists in the great quantity. So this aluminum is available very abundantly in the nature, but it is not available in free form. This has to be filtered and this has to be separated from other constituents like the ore that is called as bauxite. The bauxite refining process itself is very hard when compared to iron. Okay, so by refining this bauxite, we will get aluminum. So the chief impurities are oxide, silica, clay, and titanium oxide. So all these components has to be removed from bauxite in order to get a pure aluminum metal. So it is found in the districts of Bihar, Chennai in Madhya Pradesh in India. And how to manufacture this? So bauxite is first purified and then dissolved in fused cryolite, that is double fluoride of aluminum and sodium. The aluminum is then separated from this solution by electrolysis process at about 910 degrees centigrade. So this is very tedious process where it has to be taken out of the earth's crust, that is one tedious task, and then it has to be fused with cryolite after purification, and then it has to undergo a electrolysis process where large amount of energy is required for heating this, and the temperature, electrolysis process, all these things require large amount of energy and power. So that is why the manufacturing of aluminum is very costly when compared to iron. Now let us see some of the important properties of aluminum. So it is ductile and malleable. Its specific gravity is 2.7, which is a very important point when compared to iron, because the specific gravity of iron is more than 2.7. That is why this aluminum is replaced in most of the applications where iron cannot be used due to weight constraint. For the same object made up of iron and aluminum will have less weight. That is why they can be used in aeronautical and aerospace applications. Nowadays, most of the motorcycle engines are also made up of this aluminum. We see the example of Royal Enfield where the engine block is completely made up of aluminum only. So the melting point of this aluminum is at 658 degrees centigrade and the boiling point is 2057 degrees centigrade. Its electrical resistivity is about 2.669 micro ohms per cubic centimeters at 20 degrees centigrade temperature. Its tensile strength varies from 95 to 157 meganewtons per square meter. So this is another important property of aluminum where it stands along with iron in the race because it has a very good tensile loading capacity. It is a good conductor of heat and electricity. That is why it is used to make the engines. ICE engines are made up of aluminum and also it is a very good conductor of electricity. That is why most of the cables, the power cables in our streets, we see they are made up of aluminum because it has a very good conductivity of electricity also. It forms useful alloys with iron, copper, zinc and other metals, which we are going to see in the later slides. And it is unaffected by ordinary atmospheric influences, but it is corroded in seawater. So one bad thing about iron is it can form rust when it is subjected to oxygen in the atmosphere. Now, this aluminum is not corroded with atmospheric oxygen. It is very resistant to the atmospheric oxidation, but seawater, when this aluminum came in contact with seawater, it is very hard for the aluminum to withstand its corrosion. It will be easily corroded. Okay. Now, when there is an excess of silicon present in the metal, it does not withstand atmospheric actions also. So we have to always maintain a very low level of silica in the aluminum so that it can withstand atmospheric oxidations also. Now, when we see the uses of aluminum is used in deoxidizing molten metal, molten iron and steel, especially in the top of ingot when steel is poured in the ingot mold. So, iron and this aluminum both have different melting temperatures. That is why aluminum is used in deoxidizing molten process where it can be used to process iron or steel. The second use is it is used in the manufacture of furniture, railroad and trolley cars, automobile body, pistons, electric cables, bus bars, rivets, kitchen utensils, collapsible tubes for paste, etc. So these are all the applications of aluminum. See here, furniture is made up of aluminum, railroad, trolley cars, automobile bodies, pistons, electric cables, bus bars, rivets. Mostly rivets are made up of aluminum only. Aluminum has very good strength and it can have more load bearing capacity. Kitchen utensils, which we are very familiar with. So kitchen utensils are also made up of this aluminum because this aluminum is a very good conductor of heat. They can be used for cooking also. And they are very volatile until they are subjected to salt water. Okay. So they are used for collapsible tubes for paste. In olden days, we use toothpaste tubes which are made up of aluminum. So all these things are made up of aluminum. So because of this wide range of applications, aluminum is very good in almost every industry. Aluminum is used. Aluminum paint is used as priming coat for wood, as a protective coat for metals. So aluminum is made into powder form and it is mixed with paint so that it can form a layer of metal on wood so that it does not form any, it should not be eaten by any bugs. And the fourth point is aluminum foil is used as a silver paper for packaging of chocolates. So aluminum foil, because of this malleable property of aluminum, it can be drawn into thin sheets where these thin sheets can be used to wrap food. So aluminum foils are very widely used nowadays for wrapping food. Okay. So these are the applications of aluminum, where they can be used for different industries and domestic related applications. And after this, we are going to see what are the different aluminum alloys. So when aluminum is combined with different metals, it shows different properties. Like when it is combined with copper, so when the copper is added, while the addition of small percentage of magnesium to aluminum copper, it is still further improves the hardness and strength. So when copper is added to aluminum, it shows a very high strength and hardness than the actual aluminum. When silicon is next important to copper as a main alloying element, since its combination with magnesium it's formed a hard compound known as magnesium silicate, which is largely responsible for the hardness obtained on the treatment. So when silicon is added to magnesium and with this entire mixture is added to aluminum, what happens? We will get magnesium silicate, which is very hard in nature, which can be used to prepare tools also. Okay, so these are some of the alloys. In the coming lectures, we are going to see what are the different types of alloys that can be prepared using aluminum, and further we are going to study other non-metals like copper, etc. And that is all for this lecture. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.